What's up, everyone? Buckle up for a new episode of Tech in Check. Let's dive into the basics and complexities of machinery maintenance with engineers Rich Marriage and Tony Planamento. Join us as we meet with guests from the marine and industrial world to learn about the latest technology that keeps your equipment in check and working for you.
Morning, Bob. How are you?
Morning, Rich. I'm good. Welcome to Workboat Show.
Yeah, New Orleans. Oh, gotta love New Orleans, right?
Another year in the history books.
Yeah, I know. How many have you been to? Quite a few, I bet.
Yeah, first one was the first year post-Katrina. Was that 2006 or?
I don't remember exactly,
7.
but I know, man, that was a heck of a storm, and this whole convention was flooded, I think,
Yeah,
right?
because I had just joined Sena Corp in 2005, and the first workboat was canceled by Katrina, so it was that second year.
Right. So tell me a little bit about Regal Rexnord and the history of the company and your history with the company as well.
Yeah, well, a lot of change the last couple of years, as you know. My background was a mechanical power transmission guy. I actually had the realization this summer it's been 40 years.
Wow.
I don't know how I got to the 40-year mark, but...
you and I are around the same, actually.
Yeah, I started as a machinist at a company called Lovejoy, who was the former licensee of Senta when I was going through college in the mid-'80s.
Oh, interesting.
My dad got me the job.
You.
Yeah, my dad had been the VP sales at Lovejoy when I was a little kid, so I kind of grew up in the industry. But I got my engineering degree in '85. My dad and brother had a rep agency, so I joined the rep side of the industry.
Oh, I see. So you came in as a rep initially.
85. Yeah. So we had the Lovejoy line, who was still licensing Senta, but then we sold enclosed gearboxes, clutch brakes, mechanical torque limiting. It's kind of funny because it's a lot of the products that today are Regal Rexnord. So I kind of come back full circle.
Full circle, right?
But yeah, 40 years in the industry. I joined Senta direct in 2005 as their VP sales for the Americas, as you know. Sena Corp was just starting to get some good growth behind them. I think we were about $3.8 million at the time. And then in 2018, the Senta global organization was sold to Rexnord.
Okay.
So a lot of good years of growth in the family that had been running it, second generation, decided to sell.
Sure.
So Rexnord came into our world 2018, kind of changed, new world order. All of a sudden we're public traded, we're New York Stock Exchange. And a lot more product brought into the mix, which was pretty cool. My perspective, that was a good thing.
Complete solution.
Yeah. 2021, Rexnord merged with Regal Beloit.
Okay.
Another big power transmission guy, a lot of electric motor technologies, more gearboxes, bearings, mechanical PT again.
Sure.
And then here a few months ago, Regal Rexnord acquired Ultra. Ultra was the other monster in the industry. More brands in mechanical power transmission, clutch brakes, big part of their portfolio.
Okay.
So now we are Regal Rexnord, $7-point-something billion annual sale. I don't know the number, but we're 36-some thousand employees. New York Stock Exchange mid-cap.
Wow. Yeah, 36,000 is a pretty good number.
Yeah, a lot of folks. And global, just a real global reach now.
Right.
But a lot of portfolio, obviously my background, is the Senta stuff, couplings, shafting. But the Ultra acquisition specifically brought us a lot of good clutch brake technology and brands.
Yeah.
Group out of the UK called Twiflex, who's really big in the shaft brakes. Stearns with motor brakes, Wichita Clutch. Stromag, another German company with couplings and clutch brake technology, electromagnetics. So we've got a really full portfolio now, and the new tagline is Marine Solutions. So we're more than just couplings today.
Got it. Okay.
Yeah,
I mean, it's. I know you from Senta, for quite a few years now.
Yeah.
And the link coupling, which was, in my mind, very innovative and very high tolerance for misalignment.
Yeah. Senta had a great background. Our founder was a German guy named Gerhard Kirschei. And Gerhard, over the years, had more patents than anybody else in the industry. So he wasn't a coupling guy or a diesel engine guy. He was just an innovator.
Right.
His background was actually the German automotive industry. Out of his university days, he was working on a constant variable speed transmission for automobiles.
Constant variable speed transmission.
Yeah. Carson, everything was manual.
Oh, yeah.
He was working on automatic transmissions.
Oh, wow. So he's way ahead of his time.
50s, 60s. I don't remember when he got his start
Real
after
innovator
university.
type person, yeah.
Post World War II.
Yeah.
German auto industry was huge.
Yeah.
And he was part of that think
Got it.
tank.
Yeah.
But he came up with a patent for an enclosed variable speed drive that you could put an electric motor on, 1500 whatever RPM fixed, but you could mechanically vary the speed and vary the torque, the output, with his device.
Huh.
So before variable frequency drives were even thought of, this is how you varied speed and torque.
Yeah, because that's always been an issue, is how to, vary the load, vary the speed to meet the load.
Yeah. So conveyor drives, material handling, industrial
large
markets.
pumping systems.
Yeah, pump drives.
Yeah.
So that was his start. I think it was Deutz was trying to develop a centrifugal clutch for a flywheel diesel engine application.
Okay.
Disconnected idle speed, connect at engine speed.
Okay.
With the coupling elements of the day, all the screws went in the axial direction, and Gerhardt couldn't get the clutch to work. So his first patent was our Senaflex A, that black rubber donut coupling.
Oh.
And he switched every other bolt around radial and pre-compressed the rubber donut to transmit the torque. But now he was able to put clutch shoes around that element, and centrifugal speed would allow it to expand out.
I see.
So he made a clutch, Senta, centrifugal clutch was our first product.
Oh, wow.
So
now, that product is not.
No, we still sell them today.
Do you really?
The Mexican Navy is a great local example because they bought a bunch of patrol boats out of Sweden. And if there's not room behind the engine, like to a water jet with a short space, can't drop a gearbox in there. So we still put that centrifugal clutch right on the flywheel. You idle down the engine, you disconnect the jet. So it's a poor man's transmission.
Clutch.
For water jet drives.
Right.
But still sell a lot of that product to the day. And then that Senaflex A rubber element is still our lead, probably by volume, by far.
Yeah.
But over the years, he got into bigger and bigger couplings. And then I think it was probably the early 90s, really started to grow into marine transmission, or marine propulsion stuff. Came up with 2 patents. One of them's right here, the Senaflex R. And we've got one called Senaflex Dual Stage. Because the industry was having a big problem with gear chatter.
Yeah.
Low speed, low load, the gears would sit there and rattle around.
Right.
So the dual stage and the R coupling patents really put us on the map with the guys like Twin Disc, ZF, Ranches, the gear, close coupled gear people.
Yeah.
And then he took, the next step was the intermediate shaft,
Bob,
the
I
side
gotta
of the
say,
drivetrain.
you really know this company. I am impressed. Bob, you really know this company.
I call it mental lint. It's stuck.
Anybody, you're born into this, man.
Yeah. It's been a lot of fun. Again, 40 years, how did that happen? But the next step for Gerhardt was intermediate shafting.
Okay.
And from his patent to that Senaflex A element, axial radial screw.
Right.
If you look at the dog bone, as they call it, the Senalink, it's a radial screw and an axial screw.
Yeah.
But that
So that was his whole, that was a big thing for him, was...
That's what he figured out.
Yeah.
Just the...
everybody was thinking axial
Everybody's
screws.
going this way and we went this way.
Yeah, you guys turned it around. 90, orthogonal.
But if you think of the dog bone itself, the radial screw is an elbow. It moves this way.
Yeah.
And then the axial screw gimbals like a wrist.
Yeah.
So it's a constant velocity joint plane with really high angular and axial displacement. So you put one of those on either end of a shaft, and now you get radial displacement.
Yeah. So it can really handle a significant amount of movement.
Yeah, so we got into intermediate shafting, and we also put the link then on a coupling, because the world started to then soft mount the diesel engine.
Right.
Your background, noise, vibration.
Right.
With the soft mount engine, that engine's going to move a lot more. So the coupling now needs to have the capacity to do the same.
Right.
So the dog bone gives 2x angular and axial compared to that diaphragm technology that everybody had been using.
Right. When they went to soft mounts, it changed the world about
so
couplings.
A couple of the key patents, again, we started with the dual stage and the R coupling, and then grew into the dog bones, the Senalink, really put us on the map. The next enhancement, in the mid-90s, we started with carbon fiber for the shaft material. The marine industry, as you know then, was really getting into lightweight aluminum, high-speed ferry, became a big thing.
Yeah.
So how do you get mass out of the boat?
Right.
Carbon fiber became a natural.
Well, and then you can have a longer span without having, displacement and shaft.
Take all those pedestal
shaft
bearings
whip
out of the drivetrain.
With that whirling.
Absolutely.
Yeah.
So I think from a capacity side, I think we can wind on a mandrel up to about 12 meters. Effectively, I think we made shafts up to like 8-9 meter in a single length.
8-9 meters.
Yeah,
That is a long shaft line.
And a ton of power. We've gone into megawatts.
Support, with one support on each end. That's it.
Yep. Engine, flywheel.
It's amazing.
Back to the drive.
Yeah, I mean that's huge.
Yeah. And power, we're not constrained really. There's not a 4-cycle engine in the world that we can't put our product onto.
Nice.
So from that little bitty pleasure craft world, ski boat, wake boat, all the way up to the biggest ocean going vessels.
Sure.
Our market has expanded.
Yeah.
And then, again, then back to the recent acquisitions and mergers. Now we got all the other product to add to the mix. The clutches, the brakes, the shaft brakes.
A massive offering.
Yeah.
In the driveline world.
I wish I had 40 more years.
One-stop shop. So, you want to talk about your services side? Like, what does Rexnord offer in the way of, from once customer comes to you with a need, and take me through that.
Yeah, kind of a pet peeve service, my opinion.
Yeah.
Service as a coupling guy is very poorly planned. Too often I'm the afterthought of either the shipyard or the owner, the port engineer, whomever.
Yeah.
They very carefully plan the engine cycle. They know to a T when they're going to tear that engine down, when they need a dry dock space. But then somebody with a wrench pulls off that coupling
guard. I'm smiling
because
you
know where this is going.
I really relate to this.
Yeah. Somebody with a wrench pulls off the coupling guard and goes, "Oh, what's that?"
Yeah.
And the rubber is shot, or the dog bones are needing replacing.
It's crazy that it's not in the maintenance planning.
No. So what I'm really trying to push, and we're trying to do this a lot through education of the distribution guys.
Yeah.
And the engine guys. And even the port engineers and the fleet owners. You guys know when you're going to dock.
Yeah.
You probably got 8-10 months out.
Right.
Somebody please pull the drawing of the coupling, the shaft. And I don't care if it's mine or anybody else's.
Yeah.
Just education of this in the market.
I've been preaching that.
Yeah. If I don't have stock, I might be 8 weeks, 10 weeks, 12 weeks.
Oh, I know.
Because I got to go to Germany.
And then they're really upset. And they're like, "Oh, what do you mean you don't have?" There's so many. There's just so many variations.
Yeah.
It'd be impossible to stock every possible.
Right. But to the
some
distributor,
components are stocked, of course.
Yeah.
But
to the distributor guys. If you're regional and you've got a fleet with 12 whatever tugboats, go survey that fleet.
Right.
Be proactive.
Yeah.
Somewhere on that boat is the drawings, and God forbid if the vessel's classed, somebody's got the class paperwork.
Yeah.
We're going to need all that in advance to plan that maintenance cycle out. And if you're the regional distributor and it's a critical part, carry stock.
What I'm finding as a service provider, we work with your products all the time, and what I'm finding is that it seems like nobody really knows who supplied the coupling. Sometimes the gear guys supply the coupling, and sometimes the engine guys supply the coupling, and it's almost like they sell it with the package
and forget about it.
And then forget about it.
Yeah.
And we have a very hard time getting paperwork on the coupling itself,
right?
To know what the coupling is, and somehow we need to better align. No pun intended.
Do you know anybody that can align?
To better align with the supplier, put it in their paperwork, in their documentation when they supply that engine, or they supply the gear. The coupling paperwork seems to fall through the cracks.
Right.
And I don't know what's going on there, but it's really crazy.
Yeah. And far too often it's a reactive process.
Yeah.
And I'm trying to preach to make it proactive. Because somebody's got that stuff. If the shafting and the coupling came from the Z-Drive guy, it's in their packet.
Right.
If the vessel's classed by DNV, somebody's got those survey documents. They have to be on the boat.
Right.
The chief's
well, it's
got
also
them. Somebody's got them.
Talk a little bit about the life cycle, the inspection criteria.
Yeah, good point.
Give me a little bit more on that, because how do you inspect the coupling? What do you look for?
Yeah.
What's the proper protocol? Like that's a little confusing as well. Coupling.
Yeah, what to do, how to do it, when to do it.
Yeah, exactly.
Another pet peeve.
Yeah.
And many of us in the industry do the same. A lot of natural rubber. Natural rubber as a material, somewhere around 10 years, think of the tires on your bicycle. They're
Sure.
going to harden up.
Yeah.
The rubber's going to cross-link. The most important thing there is the shore hardness of that rubber is going to change over time.
Right.
So if we've done a torsional analysis of the drivetrain, and God forbid it's a classed vessel, if that element stiffens up to a point where that shore hardness changes, the TVA is invalid. So even a lot of class guys will say 10 years is kind of a hard stop.
Yeah.
New rubber. High speed can influence that. So if you're running a high-speed diesel, 1,800, 2,000 plus RPM, you might get less.
Well, let me jump in for just a second. So one of the things that happens, right, the way the coupling works is it takes vibration energy and it converts it to heat, right?
Right.
It converts it to heat. So there's a lot of heat in the coupling, and if the engine room's hotter than normal, or the vibration, the higher torsional vibration force is greater than normal because of a misfire.
Get an engine misfire condition.
Something like that. Your coupling will wear out faster, right?
It will.
It'll heat up,
Yeah.
and the heat will cause accelerated deterioration of the elasticity.
Yeah.
Because it's cooking.
Yep.
It's getting hot.
Yeah, natural rubber, again, most of the materials used, about 90 C,
Yeah.
I don't know, 183 Fahrenheit, whatever that is,
Yeah.
is a hard stop.
Okay.
The rubber will turn into black toothpaste.
Yeah.
It just melts.
Start falling apart.
Yeah. And each of the elements has a power loss limit, all of us, everybody.
Yeah.
It's in the catalog.
Sure.
Expressed in watts. So many watts of heat.
Yeah.
And it accumulates at the center mass of that rubber. And if it, you get over that threshold again, and it de-links the rubber, it turns into liquid again.
So when you say the center mass, you mean like if you look at a coupling disc, it would be the internal center of
Yeah, the outer surface of the rubber may show very little sign.
Right.
But if you cross-section it, that very center of it, you can stick your finger into it sometimes and it just comes out black, liquid, gooey.
Right, it's crazy.
If it goes total failure, you'll see
and the
that
silicon
black.
ones get a little interesting too.
Yeah, they fail a little different. Different temperature limit, much higher.
Yeah.
A big limit there is the bond line between the silicone and the metal substrate.
Oh,
that
interesting.
vulcanized adhesive.
I didn't know that.
That glue can only go up to maybe 120 or something C, depending on whose glue it might be.
Right.
But again, the temperature limit.
Yeah.
And
so
that's,
heat's a big issue.
Yeah, it's not only ambient, also it's that active energy, the vibratory torque. Mm-hmm. Your engine's got a mean torque, but you got a plus and a minus vibratory that may be in the system. Misfire, as you said, is going to make that worse.
Yeah.
That all goes straight to heat. It all goes straight to the rubber, and
Right.
that can be a premature failure.
Right.
The good thing is a torsional failure is real easy to spot. Because again, back to that liquefied rubber, you've seen it. It goes everywhere.
Oh yeah.
The other side, if the rubber has just torn, more likely then that's torque or alignment. It's a rubber band. It only stretches so far, and then it's going to tear.
Well, and that's the thing. If you're combining misalignment with torsional, boy, you're really the poor coupling's really taking a beating.
On test stand, I've seen couplings fail in the time you can start a drive, turn around, and turn back to the dyno stand. I mean, within a minute or less.
I'm amazed
sometimes.
at how robust they really are, though. I mean, I just do want to throw that out there. They can handle quite a bit.
Yeah, you keep them in their happy zone, and they will last the life of the other equipment.
Yeah.
And back to my pet peeve on maintenance, but at some time you got to redo that engine.
Right.
You got to do a lower, you got to do an upper, whatever. You're going to repower.
Yeah.
Let's go back to the proactivity of let's plan that then.
Sure.
Because they don't last forever. I had a fleet guy return a set of dog bones after 17 years and 120,000 hours. They look brand new. But
good ventilation.
Yeah.
and good alignment.
Good maintenance practices for sure. But 10 years, 50,000 hours.
They must have sprayed it with Armor All.
Their boats are pristine. They're spotless. Yeah. They take good care of their product. But 10 years, about 50,000 hours might be a time limit.
Yeah. That's what we found. 10 years seems to be the magic number.
Yeah, but when are you doing your engine? If you got 20,000 hour intervals,
yeah,
maybe that second interval, 40,000 hours.
Sure.
Because you're putting a lot of money and time in at that point.
Yeah.
This stuff is not big dollar compared to an engine overhaul. Just put it in your budget. Proactively, find your drawings, find your class data, and get it to whoever, the local dealer, yourselves.
Yeah.
Plan it.
It's, again, it's, and tracking down to make sure you're getting the right parts.
Yeah.
But, so what we should allow for parts is what, a 6-month lead time? Start thinking about it, 6 months ahead?
Yeah, planning 6 months out.
Yeah.
And again, the boat guy knows he's got a dry dock he's got to plan.
Yeah.
This isn't a last minute thing.
No, they should, and
Now
the
the
coupling needs to be part of that.
Yeah, the other side is a critical failure. You know, you wind something in the wheel, you go aground. You can have a catastrophic unplanned event.
Sure.
That's the proactive time to have a local distributor resource you're working with who's planning your fleet critical spares. Maybe you got some on your own shelf, but you got a backup plan. Because if you come to me on Sunday afternoon at 2 o'clock and say, my boat's broke, I might be weeks and months before I get
know in the past, before this this whole global supply chain thing, you guys were amazing. You used to be able to respond and get me stuff pretty quick. In my case, in our case.
Yeah.
But I have seen a change.
I think everybody in this room would agree with that statement.
And it's not been easy.
No.
It's not been easy. So you really do need to give it more thought these days than you did in the past.
Yeah. I mean, everybody blames COVID, but the supply chain disruptions are real, and they're not done yet. We're still seeing it. Sub-suppliers, raw materials.
Yeah.
Everything is just expanded out.
Sure.
Things that used to be 6 week are now 12 week.
Just getting metal.
Right.
Getting castings,
finding resources, people. The sub-suppliers don't have the resources they used to have.
People are, there's just not enough work. The workforce globally is shrunk.
Different times. I hate to say the word, but inventory, stock, products got to be available.
Yeah.
But it can be intelligent stock.
I think everybody got shifted to this just-in-time mentality.
Yeah.
But
lost focus.
For some things, you can't do that.
Yeah. There's not a lot of variability in the rubber elements. Shore hardness. But it's inevitable. Somebody will fail a 70, and I've got stock on a 50.
Yeah.
I don't know the fix of that.
No.
Yeah.
Yeah. It's a challenge.
Hey, back to your comment on the what to look for.
Okay.
The rubber's pretty telltale. The two big things, and we've got a manual, a document that'll give you all the guidelines for inspection. The surface of the rubber over time will develop cracks. It's kind of normal. Again, think rubber band and it's being stretched.
Sure.
It's going to start to crack. There is a depth limit to the crack based on the size of the element that we will allow.
Right.
The other thing that'll happen to the rubber over time is it'll take a permanent twist, a permanent set. It's rubber in shear. It's being twisted by torque.
And over time
it will twist.
It takes a permanent set,
Yeah, so in our manuals we'll give you an allowable delta of so many millimeters that element can twist. It's easy to measure. You make a little triangle out of it, you measure the distance. But there's a limit to that twist, and there's a limit to crack depth, where we say change the elements out.
I have a question on a crack. So you can operate with a crack coupling. I mean, it's not ideal, but it can happen.
Yeah.
As long as you're within the limits. Now, with cracks, you got that stress riser at the corners. Does it help to grind it, like circle it out a little bit so you don't have that stress riser anymore?
Yeah, you can.
Or is it better to just leave it alone?
No, it's you're right. It's a stress riser, and if you can make that a more uniform shape,
sometimes
that's not
you
a bad
gotta keep
idea.
Going, right?
Yeah.
So in the marine business,
it's not something we really stress and strongly recommend.
No, and I'm
but
sure
I know
you
in
don't
the field
want,
you can do it.
Yeah. No, you don't. I'm sure you got to be careful.
A little ball mill grinder and just normalize out that crack.
Yeah.
Get that rubber back to a more natural state. And
then
you can keep running. It's time to start planning a spare, though. But
okay, yeah, no, I agree.
Yeah.
It's good to have a spare, but the problem with spares is then you got shelf life of spares, right? So
rubber
that becomes
again.
Another.
That number might be about 5 years. A lot of people will say everything's date coded, so you can manage that. You can do your inventory management.
But I mean, if you're in a critical, like if you're in a situation where you cannot afford any downtime whatsoever, and these
you better have a spare
ships
on
are
hand.
expensive assets.
Yeah.
And they have very high daily operational rates.
Yeah, yeah.
And you got to keep it going, right? You got to keep it running.
Yeah.
So
the other side of that spare storage,
the spare's cheap insurance.
Exactly. Storage location's important too. It's rubber, so anything that's going to attack rubber is a no-no. UV, ozone, oil,
so keep
solvents.
It cool,
keep it
dry.
cool, keep it dry. Keep it in my packaging.
Yeah. Right.
And the other thing is store them flat. The big rubber elements.
Yeah. Don't get it so where it's taking a set.
Yeah. You stand them up on edge and they will sag.
Really?
Over time.
Don't tell me people have done that.
Yeah. I will not admit that. No.
Oh boy. Let's store coupling vertically.
And again, the manufacturers like ourselves all have. We got storage instructions. They're in the booklets. Please follow them. You read booklets, don't you?
Oh yeah. Every day.
Yeah. But yeah, the maintenance thing is a real pet peeve. You got to plan it. We recommend annual inspections. How hard is that? You're doing other stuff periodically. You're checking your oil, you're checking your transmissions, you're looking at your bearings. Put your eyes on the coupling.
It might be helpful to get some kind of somehow to get that knowledge, like things like this.
Yeah.
Get that knowledge out to the industry that, hey, this is a component you need to keep an eye on.
Yeah. No.
Don't just
today you can even.
It's under the coupling guard, and everybody's like, "What?
Yeah.
What coupling?"
Out of sight, out of mind. Yeah, and
there's a lot to
YouTube trainings, something like that, little video presentations.
Yeah,
That's a great idea.
You got to get that knowledge out to the industry, and everybody will be happier for it, right?
Absolutely. Make my life easier.
We want to keep them.
Make you more money.
Yeah. No downtime. No downtime. Hey, listen, I'll be happy to inspect them for them.
Absolutely.
Yeah. And then. All right, so moving on, so monitoring the coupling, making sure your coupling is, it's probably not a bad idea. What we advocate is, do an annual alignment check on your machinery. You throw a laser on it, check the alignment, and at that same time, inspect the coupling, and voila.
And let's be crazy and document that.
Yeah, once a year.
Yeah, take a few photos.
Make it part of your maintenance process.
Yep. If you're seeing cracks, measure the depth, document it, photograph them.
You get your alignment,
throw it
get
in your
your
log.
coupling inspection,
Yeah.
and you're good to go.
Yeah.
We also have the shore hardness tester, right, for the rubber.
Yeah.
That doesn't hurt, right?
No, it's not a bad idea.
Because you can monitor that and trend it.
Yeah. And that's exactly the only thing you can do is trend.
Yeah.
Because that surface is all you're able to check with those. And that will harden over time. It's normal practice. Yeah. You can't get to the core of the rubber without cross-sectioning it.
Yeah,
and that's the important
destructive,
part, the inner surface of the rubber.
Sure.
But yeah, surface checking
give you an
and trending
indication,
it
right?
is
It'll
a
give
good
you some
idea.
kind of idea.
Yeah, yeah. I mean, there is a bandwidth of that shore hardness that even class will allow. But yeah, you get the boat brand new, set your baselines, do your annual inspections, and trend it.
I've noticed too, in the last few years, class is starting to open their eyes to this. I'm getting class surveyors paying more attention to the couplings.
Yeah, yeah.
Where in the past they didn't even think about it.
Yeah, they turn an eye.
Yeah.
Now, we've had a lot of scenarios. Maybe I can't get quickly a classed product. I've seen them allow just put an element on, get the boat running, and order in that backup.
Yeah.
So we can get the classed and the 3-2 material and all the documentation in hand. Sometimes the local surveyors will be flexible with the owner, the port engineer guys.
Yeah.
It depends on that local relationship. But the class side of this is sometimes challenging.
Yeah,
I
know. Getting the certificate.
I need shipyard and hull number. For the
they
paperwork.
don't always understand too. The class surveyors not always understand that. You don't need to replace the entire coupling, just sometimes just the elements.
Yeah, the torque transmitting and the wear elements.
Yeah,
absolutely.
Exactly. Moving along, do you have any industry news, anything on the horizon that you want to talk about? Any exciting developments?
The coolest thing going on, really, and I go to a lot of the conferences and whatnot, is lowering emissions. Everybody loves the word green.
Yeah.
But it's real, and it's going on. And the hybrid side of the industry is really starting to come along. Through our Stromag brand now, we've got a 2-in-1. We've got a clutch and a torsional coupling combined unit. You're starting to see a lot of the gear guys now include a power take in on a pad into a gear through a clutch.
For like an electric motor or something like
Yep,
that.
yep. You're going to pull your motor horsepower down a little bit maybe, and you're going to drop a 500 kilowatt electric motor on a PTI. I think those are cool because now there's one more coupling in the drivetrain. But what you really got to watch is the torsional vibration analyses, the torsional dynamics of that system change.
Yeah.
It's not only more inertias and masses thrown in, but operating conditions of that boat. When are you going to run the diesel? When are you going to run the electric motor? What's your power profiles through those modes?
Yeah.
We can plug all that into the TVA calculation, but those operating conditions can really change what's going on through that rubber. And if we don't have those conditions, we can't do a good analysis. So hybrid is real.
Are they clutching couplings? They declutch?
Yeah, that electric motor or that engine drive.
A lot of times they'll run the motor and use it as they'll use it as a shaft generator.
Exactly.
So they'll run it as a motor or a shaft generator.
Yeah, charge the batteries.
Yeah.
We did the first hybrids actually with Foss, the mid 2000s somewhere.
So they got a lot
Cummins
of operating
engine.
experience.
Yeah, Cummins engine, a clutch, a torsional coupling and a little shaft, a motor generator inline, and then another little shaft back to the Z drives.
Okay.
So you need to clutch the diesel in and out when you're going to do the motor.
Yeah.
If you've got it the other way where the motor's going into a gearbox, you got to clutch the motor in and out from that side of the drivetrain.
Yeah, one or another needs a clutch.
Yeah, so the Stearns, the Wichita, some of these other brands we've got now fit right into that market. The other side of this, I can do a great TVA. I need the data, I need the operating conditions.
Which is always challenging.
When you get that boat done, the other thing I am preaching is, hey, it's time to call folks like yourself. Get on that boat at sea trial, get your data collection, and let me validate the TVA.
Let's do a torsional.
Let's make sure we didn't miss something.
Right.
The data's real, the TVA's theoretical.
Yeah.
So that data capture side, especially if you're going to build a fleet, you're going to build several of it.
Yeah.
Do that first one, do the data capture,
Yeah.
and make sure we know what's going on through that system. Hybrid, the other thing going on big, everybody's arguing what's the right solution. We don't know it yet. A lot of battery power, a lot of alternative fuel.
Yeah. Right, it's still evolving.
Yeah, battery power, great. Electric motor, you still need a coupling there somewhere, okay. But the fuel side is a big question mark to me, because you're probably changing the torsional dynamics of the engine.
Sure.
What drives that is those cylinder pressures.
Yeah.
Because something's still going to go bang.
Right.
To move that piston to turn that crank.
And they've been getting higher and higher.
Yep. Tier 4 was great for us because those engines became torsionally much more active.
Yeah.
And that all went right to that coupling.
Right. And rubber's a great absorber of that
Best
energy.
damping material in the world. Yeah. But the hybrid or the alternative fuels are doing exactly the same thing. Because methane doesn't burn the same as ammonia, doesn't burn the same as low sulfur, doesn't burn the same as diesel.
Yeah.
We need to partner with the engine guys to understand those mass forces in that cylinder when whatever that fuel is goes bang.
Sure.
Because we can then model that into our TVA.
And
then again the data
sometimes
capture.
they use dual fuel and they change.
Right.
That's even more fun.
Yeah, and some are more prone to misfire than others. Natural gas, a lot of natural LNG engines, you'll see a lot of misfire.
Yeah.
But again, combining the TVA up front and then that data capture after the boat's on the water, because we're gonna learn a lot through these new industries.
So that's where you see there's more and more going on with hybrid.
Exactly.
And that's a big future for you guys, and that's going to be more challenging.
Yeah. Everybody says diesel is dead. Diesel's never going to go away.
You need that power.
But you can't replace the power density of an internal combustion engine.
Not yet.
So we'll fuel it with something different.
Yeah.
Till we go full circle back to your old days and go nuclear. Who's going to have a nuclear power unit that's a module that you can drop in a pleasure craft and power the boat? What's the future? I don't know, but I don't have another 40 years to find out.
Right now, the nuclear would be the cleanest option, but where that's going gets everybody's, nuclear's
anybody's
one
best
of those
guess.
words that gets everybody on edge.
Yeah, absolutely.
So we just don't talk about it.
Yeah, no. But what's that future solution? We don't know yet.
Yeah.
But it's going to change. That's a given.
Yeah. So to wrap it up, what takeaways do you want to have based on our conversation today?
Just the importance of that proactivity and that partnershiping. Plan your maintenance cycles out, and from my perspective, the best thing I can convince a port engineer to do is to know people like yourself.
Yeah.
And engage at that maintenance cycle or that time when, hey, we're having a problem on the boat. What's going on? The quicker you can get to the problem and solve it. Everybody fires arrows at the coupling. It's the coupling's fault. You're chuckling because you've seen this.
That's an easy target.
The only thing I can do is be out of balance.
Bow and arrow, baby.
First, 1x engine speed, I'm out of balance. That's simple. You can fix that. Everything else I react to. It's an external input and that's what I do. I'm the fuse. I'm the part that should break.
Right. Right. You don't want to break a crankshaft.
Oh, it gets a little expensive.
Yeah.
But that's where we promote folks like yourself. Do that maintenance cycle. Do that data capture. What's going on?
Sure.
Make everything happy.
Don't forget about my coupling.
Yeah. Happy boat.
We're here for you.
Absolutely.
But don't forget us. All right. Well,
so that's it.
Thank you very much. Appreciate it, Bob.
My pleasure. Thanks, Rich.
Good talking to you.
You too.
Thank you.
Bye.
Thanks for listening in. We hope you enjoyed our deep dive into this week's tips and tricks for equipment optimization. Want to learn more? Head over to AME's LinkedIn, Facebook, Instagram, or YouTube included in the show notes, along with details from this episode. That's all for now, folks. See you next time.